Down there, life continues. The traffic is awful, stocks go on trading, and Star Trek is still showing.
Hello, grade 9 learners, and welcome to today's Natural Sciences lesson. My name is Sianda Madlala, and this lesson is proudly brought to you by the Gauteng Department of Education. Right, in our term 2, still exploring metals and materials, right? Today's topic will be on the reactions of metals with oxygen. Are we together? Reactions of metals with oxygen. So now let's quickly look at our lesson objectives. Right, these are the following things that we should achieve by the end of the lesson. The first one there, we need to be able to explain that some metals react with oxygen during burning. Also, we need to be able to describe the formation of a metal oxide. Not only that, we need to be able to give the general equation for the reaction of a metal with oxygen. And all this information is found under the CAPS document on page 65. Right, now let's move on to our pre-knowledge, right? In grade 9, which is the same grade, then in the previous topics, we have discussed the topic of compounds, right? We said that compounds are made up by two or more different elements that are chemically bonded in a fixed ratio. We then talked about chemical reactions, right? So, in our examples, we said that in a chemical reaction, you have what? Two or more compounds chemically bonding with each other to form new compounds, right? And in that process, no atoms are lost or gained, right? So they are simply rearranged, as we have said in the previous topic, right? So as you can see here, there's some rearrangement of atoms to form new compounds, right? So just to remind you of what we talked about in the previous lesson. Now, let's jump on quickly to our baseline activity. So number 1 says, why can we not change the subscripts in the formula of reactants and products when we want to balance an equation? Remember in the last lesson we were balancing equations as well, right? So why can we not change the subscripts in the formula of reactants and products when we want to balance an equation? Then number 2, write the balanced chemical equation between carbon and oxygen to form carbon dioxide. Then number 3, write the balanced chemical equation between hydrogen and oxygen to form water. So I'm going to give you a quick 4 minutes to complete this activity. Welcome back, grade 9s. Now, before we continue to look at our solutions, please remember that you can simply send us your WhatsApp on our WhatsApp number, your picture of your answers, any question or comment regarding this lesson, right? Our WhatsApp number is 079 578 2908. Now, let's look at the solutions together. Number one, why can we not change the subscripts in the formula of reactants and products when we want to balance an equation? Right? This is why, right? This is because it will change the formula of the compound, which then represents a different compound and not the one involved in the reaction. Remember, we said that compounds, they are two or more elements in a fixed ratio, right? So once that ratio changes, it also changes the type of compound in the reaction, right? So this is why we cannot change the subscripts. Then number two, write the balanced chemical equation between carbon and oxygen to form carbon dioxide, right? So the equation is C plus O2 to form CO2, right? Carbon plus oxygen to form carbon dioxide. And number three, write the balanced chemical equation between hydrogen and oxygen to form water, right? So the balanced chemical equation is 2H2 plus O2 to form 2H2O, right? So it's 4 hydrogens plus 2 oxygens to form what? 2 water molecules, right? So give yourself a tick, and if you need to copy down your corrections, I'm going to give you another quick minute so that you can copy your corrections quickly. Then after that, we shall continue with our lesson. Welcome back again, grade 9s. Now let's carry on with our lesson. Right, before we carry on, let's look at the important terms that are associated with this lesson. The first term there is combustion, right? And we term combustion as the rapid chemical reaction with oxygen that produces heat and light, right? So it's a rapid chemical reaction with oxygen that produces heat and light. So simply it's burning something in the presence of oxygen, right? Now, oxide. Oxide is a compound that is formed when a substance reacts with oxygen, right? So it is a product, right? It is a compound that is formed when a substance reacts with oxygen. Then we have metal oxide. And a metal oxide is also a product, right? It is a compound which is formed when a metal reacts with oxygen, hence the name metal oxide. Then we have rusting, right? Which is the slow chemical reaction of iron with oxygen in the air and in the presence of water. Then we have corrosion, which is a process where a steel is damaged or weakened by a chemical reaction, right? That's all for our terminology. Now let's get on to our main meal for today. Reactions of metals with oxygen, right? So, but before we go further, let's start off by talking about this oxygen, right? So now if you think of your other subjects where you're talking about the composition of the atmosphere, and it tells you that the atmosphere is made up of various gases that include oxygen as well, right? So it should come to mind that this oxygen that you are talking about is coming from the air around us, right? It is the one that is reacting with these metals, right? So remember that also oxygen is colorless and it has no smell, right? So it is found all over around us because now oxygen contributes about 20% of the Earth's atmosphere, right? So it makes up 20% of the air that is all around us, right? So if you look at this picture here, you have what? Molecules of oxygen scattered all over this atmosphere, right? Or all over the air around us. So this is where we find this oxygen that is going to react with metals, right? So sometimes we become confused as to how did this certain metal rust, right? It's because of what? The air around us contains what? It contains oxygen and also it contains moisture, which we're going to talk about in the later stage, right? So this oxygen is in the air around us and it is colorless and also it has no smell, right? So now, the general reaction of metals with oxygen, right? So we say that some metals react with oxygen during burning, right? So some metals they react with this oxygen during burning, and this process is called combustion, right? As I said, that combustion is burning a substance or something in the presence of oxygen, right? So what these metals undergo combustion when they react with oxygen. So this combustion, remember that it produces what? Heat and light as well, right? So it is a rapid reaction that produces heat and light. So looking at this example here, right? You have hydrocarbon reacting with oxygen to form carbon dioxide plus water. But looking at this, right? Looking at this fire, we have some hydrocarbon here, right? And now this fire has started and we have some oxygen, right? We have some oxygen entering the reaction, right? And remember, this is what? Combustion is entering the reaction, and now you have what? Products such as carbon dioxide being released, right? Products such as carbon dioxide and water in the form of water vapor and H2O, right? So now, they react with this oxygen, right? And we call this process combustion. And in the process, they produce heat and light, right? So let's look at more of this lesson. So now, we say that when a substance reacts with oxygen, the reaction is called oxidation, right? It oxidizes, right? When a substance reacts with oxygen, it oxidizes and the reaction is called oxidation, right? So a new compound out of that reaction will be formed and that compound will be called an oxide. But because today we're talking of the reactions with metals with oxygen, right? So when a metal reacts with oxygen, it forms a metal oxide, right? So when you burn a metal in air, the metal reacts with the oxygen that is found in the air around us, and a metal oxide is formed. So what do I mean by that? Let's look at this picture here, right? We say that a metal oxide is formed. So when looking at this frame of a bicycle, right? It has been standing here for quite some time, right? Probably months, years or so, right? Look at this original color, right? It is somehow silver, right? But as time goes, as it reacts more with oxygen, right? As it reacts more with oxygen and also in the presence of moisture, it forms this certain metal oxide, right? That now we see on top of this frame, right? The color has changed, right? So remember, evidence of a chemical reaction also includes color change, right? So now looking at this, the color has changed, right? To prove that it has reacted with oxygen and it has produced this certain metal oxide that we're still going to talk about. Right. So this is the general reaction between a metal and oxygen, right? Just to remind you, the general reaction of a metal with oxygen is metal plus oxygen to form a metal oxide, right? So now there are different metals, right? There are different metals that may react with oxygen To mention some, potassium, right? For example, potassium can react with oxygen to form potassium oxide. So now we're talking of the general equation of a metal, any metal, with oxygen to form what? A metal oxide, right? So just to remind you here, in this reaction, particular reaction, our metal and oxygen, those are our reactants, right? They are the ones that are reacting with one another to form this product, right? To form this product, which is a metal oxide. So the metal and oxygen are our reactants, whereas the metal oxide is the product that is formed after the reaction has taken place. Right. So for example now, we're going to look at the reactions of magnesium with oxygen. So when looking at your periodic table, right, magnesium is under what? It is under metals on our periodic table. So that's why we're taking this magnesium as an example, right? So just a reminder, magnesium is a metal, right? So we're going to look at its reactions with oxygen. So when magnesium reacts with oxygen, or when it is burnt in air, right? Air that contains oxygen, the reaction forms a magnesium oxide as a product, right? Remember the general equation. We said that a metal plus oxygen, they form a metal oxide. And in this case, we're being specific as to which metal we're talking about here, right? We're talking of magnesium reacting with oxygen. So when magnesium reacts with oxygen, it's going to form what? A magnesium oxide as a product, right? That magnesium oxide is a white powder, right? It is a white powder in appearance, and this is the weight equation for the reaction, right? You have the magnesium and oxygen reacting together to form the magnesium oxide, right? So just to test your minds, which ones are our reactants here, right? It is the magnesium and oxygen, right? Those are our reactants, right? Those are our reactants. And the magnesium oxide is our product. Are we together? So which one is the product here? It is this white powder, right? It is this white powder which is a magnesium oxide, right? It forms after reacting magnesium and oxygen. So let's look at some examples, right? Again. So here is a magnesium strip, right? It is a metal. It is a type of metal, right? So when you burn now this magnesium strip in the presence of oxygen, as you can see now, we experience a very bright color during the reaction, right? We experience a very bright color during the reaction. And now the product is that white powder that we get at the end, which is a magnesium oxide, right? So here is a balanced equation of this reaction, right? Remember, magnesium is Mg, right? Plus oxygen to form what? MgO, or magnesium oxide. So the balanced equation of this, it's this 2Mg plus O2 to form 2MgO. And why do we say it's balanced, right? Because now when counting the number of atoms and type of atoms, they are the same on the reactant side as on the product side, right? So when counting the number of magnesiums here, there are 2, right? Because this 2 multiplies this magnesium, it gives us 2 magnesiums, right? Then plus O2, then on the product side here, this 2 as a coefficient multiplies this whole compound, then you have 2 molecules of magnesium oxide. Are we together? So just to remind you again, these are our reactants, right? These are our reactants, right? They react with each other to form this product, which are 2 magnesium molecules in this case, right? So now, let's move on. Let's look at the reactions now of iron with oxygen. Why iron again? Because iron also is a metal. Are we together? Iron is a metal. So we're looking at the reactions of iron with oxygen. So when this ion is burnt in air, the reaction forms what? An iron oxide. So when you have an ion reacting with oxygen, it's going to form an iron oxide. Are we together? So iron and oxygen also combine in different ways. And in different ways, meaning that they can produce also different products. Are we together? So they combine in different ways. So during combustion of iron in air, Fe2O3. What is that Fe2O3 that we talked about also in the previous lessons? Fe2O3 is the rust, right? So when during combustion of iron in air, Fe2O3 and Fe3O4 may be formed, right? So this Fe2O3 is the rust that I'm talking about, and the Fe3O4 is a black magnetic substance called a magnetite, right? So looking at rust as an example, right? We have this piece of iron here having its original silver color, right? But as time goes, as it reacts with oxygen and in the presence of moisture, as time goes, its color starts to change, right? Its color and it starts to change, right? What causes that? It is the reaction of this piece of metal with the oxygen in the presence of moisture to form this now product. This product Fe2O3, which we call rust, right? So as you can see now, this metal has started to change color and starting to wear out, and it has rusted, right? It is simply because of the reaction of this ion with oxygen. So also a black magnetic substance can be formed, right? Which is called a magnetite, right? This is also because of a reaction with oxygen with this ion, right? And now let's look into the issue of ratio as we said, right? We said that now when the subscript changes, right, it means now it is a whole different compound, right? Looking at these two chemical equations here, they are almost the same, right? Fe2O3, Fe3O4, right? But now, this Fe3O4, the subscripts have changed, meaning also the ratio of each atom has changed, right, in this compound. So it's going to give us a new compound. Hence, this one is called differently, and it has different properties as well, right? Because it is black and also it is magnetic, right? And its chemical formula now is what? Fe3O4. So the ratio has changed, right? Hence, we have a different compound. And that's why we say also the metals or the ion reacts with oxygen in different ways. Right. So let's look at the word equation for the reaction of ion with oxygen, right? So it is ion plus oxygen to form what? Iron oxide, right? And looking at the symbol equation, which is unbalanced, it is Fe plus O2 to form Fe2O3. And we said that the Fe2O3 is what? Is our rust, right? And also now the same reaction, right? Fe plus O2 to form this magnetite, right? To form this magnetite, which has the chemical formula Fe3O4. And here are the balanced chemical equations for these reactions, right? So therefore, rust, you have 4Fe plus 3O2 to form 2Fe2O3, right? So you have what? Ion plus oxygen to form two molecules of rust, right? Then the last one, you have 3Fe plus 2O2 to form Fe3O4, right? These are such examples of the balanced equation of the two reactions of ion with oxygen, right? Now, let's talk more about this rusting. This rusting is formed as a result of a reaction between ion and oxygen, right? So rusting is a type of corrosion as well, right? Because it damages the metal, right? It is a type of corrosion. So it usually takes place when metals react with oxygen, right? Not only with oxygen, also with water, acids, or bases in their environment. right? So more reactive metals usually corrode faster than less reactive metals, right? Which is a story for another day. And now, right? Just to mention one example again, right? Sodium as an example of metals. Sodium corrodes so fast and we need to store it in oil so that we can preserve it, right? So that we know this information, right? We need to preserve it by storing it in oil. So the least reactive metals like gold and platinum do not corrode even after many years. Now, talking of gold, right? When looking at the marriage rings of our parents, right? They have been wearing them for many years, right? And they do not rust or corrode, right? This is because of what? These metals or these type of metals, they are less reactive, right? They are less reactive, so they don't engage with oxygen more often, right? They are less reactive, hence they get to last for a long period of time. Now, thinking of that ring again, right? Our parents wash the dishes, wash cars, they're always engaging with water, right? So it should have corroded or rusted quickly, right? But because of these metals, they are least reactive, so that's why they last for long periods of time without rusting or corroding. Right. So now, we said rust is a slow chemical reaction that most of us see all around us, right? We walk around, we see rusted bicycles, rusted cars, rusted fences, and so on, right? So it occurs when this ion reacts with oxygen in the presence of moisture, right? So water is needed for the rusting process to take place, and the reaction produces a complex compound which is rust, right? Which is rust containing what? Containing an orange, red, brown color, right? So this oxide is an orange, red, brown color that has resulted from the reaction of ion with oxygen, right? And that orange, red, brown color that we see on metals, we call it rust. Let's not forget that, right? We call it what? Rust. So here we have some pictures to show some examples of the metals that have rusted, right? Looking at this car, right? Probably the owner left it many years ago and it has reacted with lots and lots of oxygen and now it has rusted to become this orange, red, brown color, right? We have some nails here that have rusted as well, and we have some spanners here also that have reacted with oxygen and over time they have rusted, right? So this is what we're talking about when talking about rust. Now, here is an example here, right? A bicycle made up of iron-based metals will rust faster in Cape Town than in Johannesburg, right? Because near the coast there is more water vapor in the air, right? Not only that, right? Not only that, this is because of what? Also, the waters in the coast, they contain what? Impurities such as salt, right? They contain what? Impurities such as salts, which make the rusting process to be quicker as well, right? So rusting also is a continuous process over time and time. The metal turns into rust when the metal reacts with oxygen. So after a very long time, holes will start to form, right? Holes will form in the metal and eventually the object starts falling off. So now here we have activity 1, right? So firstly, let me read this case study for you so that you have an idea of what we're going to talk about in this activity. So you have a rusted bicycle and you have some people cycling here, right? So now, it reads as follows. It says, the Cape Argus Pick and Pay Cycle Tour is the largest time cycle event in the world. Cyclists from around the world travel to Cape Town to cycle 110 scenic kilometers around the Cape Peninsula. So the event can be completed on many different types of bicycles, right? So let's talk more about this activity. Let's look at the questions. Number 1, it says, Some bicycles are made up of metal containing iron which can rust. So in your own words, write down a definition of rust. Number 2, two learners are training for the cycle tour. Johan trains in Kimberley and Nosipo trains in Port Elizabeth. So think of a reason why a bicycle in Port Elizabeth rusts faster than a bicycle in Kimberley. Then number 3, suggest a method that the learners can use to protect their bicycles against rust. Then number 4, cyclists using many different bicycles enter the Cape August Pick and Pay cycle tour. So do you think that a rusty bicycle will affect a cyclist's performance? Explain your answer. So I'm going to give you a quick 5 minutes to copy and complete this activity. Then after that, we shall mark together. Welcome back, grade 9s. Now let's look at the solutions together. Right. For number 1, right? Rust is a reddish or yellowish brown flaking coating of iron oxide that is formed on iron or steel by oxidation, especially in the presence of moisture. Then number 2, the answer is Port Elizabeth is near the sea, and so there is more salt water in the air than in Kimberley. That's why the bicycle in Port Elizabeth would rust faster than the one in Kimberley. Number 3, we can prevent the rusting process by keeping the bicycles clean, dry, or storing it indoors, right? Some can talk about painting the bicycle, galvanizing the bicycle, chrome plating, and so on, right? And number 4, a rust chain will not move as smoothly as an oiled chain, right? So definitely this will affect the performance of the bicycle, right? So I'm going to give you another quick 2 minutes to copy down the corrections. But before that, remember, if you want to send in your answers, questions, or comments regarding this lesson, our WhatsApp number is 079 So see you after the corrections. Now let's carry on with our lesson. Right. So we said that there are ways that we can explore and use to prevent rust, right? That is the fortunate part about this, right? We can be able to prevent rust so that we can preserve our goods for a long time, right? So now, it is very important to prevent rusting, right? So that you preserve our goods for a long time, right? So that they last longer. And we can do this by preventing the oxygen from the air and water coming into contact with the steel, right? So I think now already we have an idea as to what we need to do to prevent the oxygen from coming in contact with the steel or the iron or a metal. Are we together? So now, these are the various ways that you can use to prevent the air and water from coming into contact with the steel, right? The first one there is galvanizing, right? We can use the process of galvanizing to prevent rust. We can use painting to prevent rust. We can use electroplating to prevent rust. And also we can use oiling, right? So we're going to talk about these one by one. Starting off with galvanizing, right? So now, how do we galvanize objects, right? We galvanize an ion by coating it with what? With a thin layer of a more reactive metal, right? With another thin layer of another metal, right? So this forms a protective layer for the ion as a result, right? It forms a protective layer for the ion. So when looking at this tank, which is filled with water, it has been galvanized, right, to prevent it from rusting, right, so that the oxygen and the water, they first react with the layer of paint, right, or the thin layer of what? Of another metal, of a more reactive metal, right? So that it does not get to the ion itself, right? So looking at this, right? So we often see cars that last longer as well, right? So our manufacturer here, VW, is showing us what? A galvanizing process, right? When it's putting that thin layer of a more reactive metal inside to galvanize it, and so that it covers the core metal of the car and it prevents it from rusting, right? Now, another process that you can use to prevent rust is chrome plating, right? And chrome plating is another way of protecting steel or iron, as I've said, right? So electrolysis is used in the process, right? So it is used in a process called electroplating. So the electrolysis reaction deposits a thin layer of chromium on the steel, right? So the chromium it's a less what? Reactive metal, right? So it protects the steel because chromium does not rust. So what does it do? Instead, it forms a shiny, attractive surface and is therefore often used to produce components of motorbikes and cars, right? So looking at this example here again, you can see this part of this motorbike is having a what? A layer of shiny and attractive chromium, right? To protect the core steel or the metal of this motorbike. And also we have chromed our mag wheels so that we keep them shiny and for a long time. So as we've said again, another way which you can use to prevent rust is by painting iron, right? By painting iron. This is simply because of what? The paint prevents the metal from coming into contact with water and oxygen in the air. So the water and oxygen in the air, they firstly react with the paint before they get to the metal, right? That's how we save or prevent rusting when by painting iron. So for example, we paint our ships, bridges, fences, and many other structures to protect them from rusting, right? So also here is another example of a person painting their fence, right? To protect it from rusting, right? Because if not, right? Or if the paint is scratched, the iron underneath will come into contact with the water and oxygen and start to rust and become something like this, right? So if not painted, what is going to happen? The iron is going to easily come into contact with oxygen and water, then it starts to rust, right? And also, as time goes, if the paint starts to be scratched, the iron is vulnerable now, right? It starts to react with the oxygen and also the water and starts to rust. Also, we can use oil to prevent rust, right? So now, know the saying that the oil does not mix with water, right? So we can protect some structures against rusting by applying a layer of oil because oil prevents the rusting by repelling water, by pushing the water away, right? So we can simply oil our objects so that the oil repels or pushes the water away and the water does not come into contact with the iron, right? So as I said that oil and water do not mix. So oil and water do not mix. The water does not come into contact with the metal underneath the oil, right? So here's an example again of oiling our is for our bicycle, right? So that it stays in this condition for a long time. So it can cycle smoothly for a long time without having the chain rusted. So now we're going to engage on activity 2, right? Let's go through the questions together. Number 1 is saying, write the word equations for the reactions that take place when the following metals burn in air. A, aluminium. B, potassium, right? And number 2, complete the following chemical equations and balance them, right? A, it's Fe plus to form Fe2O3. Then B, it's Cu plus O2 to form Now, please take 5 minutes to complete this activity. Then after that, we shall mark together. Welcome back again, grade 9s. Now let's look at the solutions. But before that, we are still waiting for those answers, comments, or any or compliments as well, right? Regarding this lesson. Right. Now let's look at the solutions. Number 1. A is aluminium plus oxygen to form aluminium oxide, right? Aluminium plus oxygen to form aluminium oxide. Then B, it's potassium plus oxygen to form what? Potassium oxide. Then number 2A, it is 4Fe plus 3O2 to form 2Fe2O3, right? Then B, it is Cu plus O2 to form CuO2, right? So now, just take a quick 3 minutes to copy down the corrections. Then after that, we shall wrap up our lesson. Welcome back again, grade 9s. Now let's wrap up our lesson by simply summarizing what we have learned for today. So today we're talking about the reactions of metals with oxygen, right? So we said that some metals react with oxygen during burning, and that is called what? Combustion, right? And some metals react with oxygen to form a metal oxide as a product, right? So those metals, for example, such as iron, they react with oxygen to form an iron oxide. One example again, magnesium reacts with oxygen to form a magnesium oxide. Then again, this iron reacts with oxygen and moisture to form rust, right? To form rust. And this rust can be prevented by painting or coating with metals such as zinc or chromium. Are we together? So that's all that we have covered for today's lesson. So let's meet again in the next lesson when we're talking about the reactions of non-metals with oxygen. So from me to you now, thank you and goodbye.